Thank you. Okay, so I'm here to talk about server-side rendering in React. Let's start off with why you should care about server-side rendering in React. Well, why should you care about server-side rendering at all? So one of the first advantages to rendering your server on the rendering your website on the server, as opposed to relying purely on JavaScript on the client side, is that your website becomes machine readable. So if you haven't had the time to build a proper API, there's still a chance that someone might be able to scrape your website and compose the information you're providing in new and interesting ways. It also allows you to get something loaded really fast. So it might take a while for the user's browser on a slow connection to download all of the JavaScript, parse all of the JavaScript, execute all of the JavaScript. Whereas if you render it on the server side, you can deliver straight away the initial view of what they should see. Another advantage is that you can show something even on older browsers or browsers you might not fully support. So with JavaScript, it's very difficult to make sure that your code runs correctly and behaves correctly across all the many different browsers and environments, and particularly older browsers. If you render on the server side and you're sending down the raw HTML, users are going to be able to see and interact with at least some of your website, even on those older devices. Another problem is that JavaScript is really slow on older devices, particularly low-end Android phones, feature phones, that kind of thing. If you render on the server side, you might actually want to disable JavaScript on the client for those browsers. And if you do that, you might actually be offering a faster experience. If they've got a good network connection, slow CPU, slow JavaScript engine, it could be faster to rely on the server. This is how Facebook looks on a feature phone. It looks something like this. And it's actually how a lot of users interact with Facebook. And this website doesn't have any JavaScript. It's purely a server-side rendered page. It just has simple links and forms. But it allows you to actually interact with the vast majority of the functionality that Facebook provides. And it's really fast, even on a really, really low-end device. So there are three approaches you could take to building what I would call a universal application, an application that works both on the server and the client side. So you could write two separate apps. You could say, we've got the engineering resources, we'll write the basic version of our site and the kind of super whizzy interactive version of the site. This is actually the approach that Facebook takes. But unless you have huge resources and a huge development team, that's a huge cost. And most small startups, most small companies, most side projects, that sort of thing, you're not necessarily going to have the time to build two complete separate apps. The next approach you could take is to architect your app as a server-side application, and then just try and improve it a bit by running some of that on the client side. The problem with this is that you don't necessarily get to take advantage of all of the latest and greatest frameworks, things like React, Angular, Ember, whatever your personal flavor of choice is. So let's ignore that. So you could take a broadly client-side app and try and run this app on the server. And that's really the approach that I'm going to discuss today, is if you were to take a React application and attempt to run that on your server and how you'd go about that. So let's think about what you need to abstract. You need to abstract away anything that's different between your different environments, your server and your client. So that's the way that you render. On the server, we're going to render to a string. On the client, we're rendering into the DOM. It's the way we handle URLs and navigation. On the server, we have this request-response model. And on the client, there's this continuous history and push state going on. Data fetching is different. In one environment, we have direct access to the database. In the other, we have to make some kind of REST calls. There's also the problem that in the client and the user's browser, we still have to render something while the page is loading. So we have sort of loading spinners and things like that. Whereas we don't render loading spinners if we're doing server-side rendering. It doesn't make sense. And there's how we handle interactivity, updates, form posts, showing and hiding bits of accordions, that kind of thing. Again, is different depending on whether you're writing a front-end JavaScript application or a server-side application. Let's start by looking at rendering. The basic flow on the server side, we're going to render to a string. On the client side, we're going to render into the DOM. sorry. So React is a library for building user interfaces. It has a very declarative API, which means that it can be directly rendered to a string. We can use this to do our server-side rendering. And it's actually quite lightweight. It's quite a lightweight approach to building user interfaces. React models everything as a complete re-render. So if we imagine a very simple React component for our home page, it could return, say, a div with some content in it. Obviously, a real application, more complicated than this, but that's the basic idea. When that gets compiled, so that previous slide written using JSX, when that gets compiled down, it actually just becomes a simple function call to react.createElement, which takes the name of the DOM element you're creating, the properties as the second argument there, and then the third argument is the content of that element. On the client side, we can use the React DOM library to render this React element into the DOM, into the document. And that renders it in with any interactivity that's built in. So more complicated components can have local state and behavior and all the rest of it, event handlers, that kind of thing. And React DOM.render gives you all of those things, binds all of those things into the DOM. And it's clever enough to do the diffing stuff so that if you re-render, the model of interaction is that every time something changes, you imagine that your entire app is re-rendered by React. But what React actually does is figure out what's changed and only update those bits. Coming back to that react.createElement call, that in turn you can think of as being compiled down to a simple object, in that that's what the react.createElement call will return. It returns an object with a type property that's div, and a props property. The props has a children property, which is essentially just a sort of special cased property, which again is that string homepage. So you can see here we've got all of the structure that we need in order to render this on the server side. We can simply recurse down through this tree and build up the string of HTML. React provides a method for us to do that. So we can use React Server. And React Server has a render to string method, which takes the React element and returns a string. So we can then insert that into our layout and send that straight to the client. So we can build a simple Node.js server here that's rendering a React element, sending it to the client. So we've abstracted away the rendering. We figured out how we're going to render to a string on the server and how we're going to render into the DOM on the client. Next, let's look at navigation. So on the server side, we render at some given URL once. We're given a URL and we render at it. On the client side, we render at the current URL, but that changes over time. On the server side, we're allowing the app to trigger navigation, which we represent as a redirect. On the client side, we allow the app to trigger navigation, and we represent that by updating the URL bar and the history via the push state APIs. But in this case, navigation could be triggered by link clicks, button clicks, that sort of thing. On the client side, we also then need to re-render the app whenever the URL changes. So there is a library on NPM, a Node.js library, a JavaScript library, sorry, called History. And it brilliantly abstracts away these different environments for us. So it provides many implementations, a browser history, a hash history, and a memory history. So the browser history uses the HTML5 push state to push updates to the URL and update the address bar dynamically. Hash history works with kind of legacy browsers support and uses the bit after the hash, because you can change that on the client side without a refresh. And then memory history just stores a location in memory. It provides the same API, but without the address bar, which means you could use it on the server side. And the API it provides allows you to push an update to the location, replace the current location, go back, go forwards, and listen for changes to the location. So all in all, that gives us the abstraction we need. On the server side, we're going to receive a request in Node.js, create a memory history with the request URL, and give that memory history to our application. And if the URL in the memory history gets updated in the process of rendering our app, then we return a redirect response. On the client side, when the page loads, we're going to create the browser history. We're going to give that history to our app to render with, and then that's it. The app can handle all the updates to the history. There's also another library that's built on top of the history API. So if you're using React, I'd recommend React Router. If you're not using React, you should still use that history library. It's a really great low-level abstraction. But the higher-level abstraction here is React Router. And React Router lets you have nested views, declarative routes. It supports server-side rendering as well as client-side rendering. And it has really great documentation as well. So if we're going to build a React application that's going to render on the client and the server, the first thing we do is create a route file which specifies the routing that's going to be used on both the client and the server. So this is simply an array of route elements that map some path onto some component. And these route elements can be nested to create a kind of nested structure of paths, and they can have dynamic segments and all of that kind of thing, but I'm not going to discuss that too much today. On the client side, we can load in the router component from React Router. We give it the browser history as the history implementation that it should use, and we give it our list of routes, and then we tell it to render that into a container. And React Router will then bind to that history and sync correctly between the history, between the URL bar and what's displayed in the URL bar and what is rendered as the app. So you can do navigation and it will keep the two in sync. On the server side, it's a little bit more work, but React Router provides this match method, which allows you to, in the absence of any actual location, any actual URL bar, take the list of routes and match some URL, some string against that. And then it calls a callback eventually with either an error, a redirect location, or the properties to render with. The reason this is asynchronous is because React Router has some more advanced functionality for doing code splitting. So you can have only part of your application's JavaScript loaded and have it load the rest in dynamically when certain routes are hit. So that's why this has this sort of slightly weird asynchronous interface. So once we've got those three things back, if there's an error, then we can simply send a 500 status code, an error code back to the user. If there's a redirect location, then we can redirect the user's browser. If we don't have any render props, that means that there's a 404, the page didn't match any of those routes. And then finally, if it matches some of the routes, we might still want to send back a status code other than 200. If the page matched one of those routes, but then when we loaded the data and checked up on things, it turned out actually there was nothing there, then we might want to send a 404 page or something like that. So to do that, we can actually see in the render props the list of routes. That's the sort of nested path that was matched. And we can look on that path to see if there's any additional data, any additional settings that we've specified. So we can add support for, say, a status property being added to the routes to control the status that's returned. Having done that, we can simply call React server.render to string as before. There's this router context, which is designed for handling the server-side rendering. You give that the render props, and then it returns the appropriate React element. And then we simply send that to the client as before. So now we've abstracted away the rendering and the routing. That feels like most of an application. You could any kind of read-only application, you can kind of sort of almost stop there. The next thing, data fetching. So on the server side, we can read straight from the database. On the client side, we're going to need to make requests via some kind of AJAX, some kind of REST API. On the server side, we'll get the user information out of the session. On the client side, the user information gets attached to the request by the browser, assuming we're using cookies or something similar to that. On the server side, we need to know when all of the data is loaded. We need some way of knowing when we have enough data to render the entire page and send it to the browser. Whereas on the client side, we need to be able to render in between states. We need to render the partial result as soon as some data is loaded, or even before any data is loaded. We want to render the shell of the application with loading spinners and the like. So one approach to this is just to sort of skip the data loading on the server side and just render a shell. So this still gets you some of the advantages of server-side rendering in that you display something really fast. You display something almost immediately because you could build those static pages. You could host them on a CDN somewhere. You can make sure that the user doesn't see that blank white page for 30 seconds while it's loading. But you don't get the actual content of the page unless you have JavaScript if you do this. So if we are going to fetch our data on the server side, then the key thing to do here is to make sure that all of our data flows through some central point. If there's some central point where all of the requests flow through, then we know that we can intercept the requests at that point. We can do things like caching and retries and that kind of stuff, but also we can tell which requests are in flight, how many requests are in flight. And we know that if we've rendered our application and there are no requests in flight, then all of the data must have been loaded. So we can simply wait until there are no requests in flight, and then at that point, send the application to the client. So connecting this single point to React, you can use React's context feature, which allows you to avoid having any kind of global variable, any kind of singleton for that central point. And avoiding these global variables is really important if you're going to do server-side rendering, because you don't want to have a separate JavaScript process for every single request that comes through. That's not going to scale very well. Context lets you avoid that. And then the next thing is you can use containers and higher order components to bind this central point, this store or client, to your presentation components, to the components that actually render the view. There's a really good article about this by Dan Abramov called "Mixins Are Dead, Long Live Composition." And I'll tweet out the link to this afterwards, and I highly recommend people read that. So I've been thinking about this data fetching thing a little bit, a fair bit, and trying to figure out how we can build that centralized point that all of the data flows through in a nice generic way that everyone can reuse. So this is highly experimental. I don't necessarily recommend you use this in production, but I've built a library called Bicycle, and it lets you define a schema for what data users can access, lets you expose that schema on a REST endpoint, and then has a client library that allows you to subscribe to parts of that schema. So if you were to use this in a simple application, you might have something like this. So I've got a list component that renders a list of items. And my list component is written as if all of the data is already loaded, as if all of the data is always available all of the time. So it simply accepts an items property, and each item has a name. So it creates a UL, an unordered list of list elements for each item. So there's nothing in that function list, that does any data fetching or renders any kind of loading spinner. And then what we can use is there's a connect method provided by Bicycle, which is this sort of higher order component. So it takes a query, which is the bit of that schema that we're interested in. So here we've said we're interested in the items, and for each of the items we want the name of the item. And then we've wrapped the list component in that higher order component. So that connect component, that connect function is just a function that returns another component. So there's nothing actually that complicated in there, and you can check out the source. It's really quite simple. But what that gives us is a really declarative way of specifying our data fetching. On the client side, if you want to use Bicycle, you simply wrap your entire application in a provider component, and then you put the client in there. And what that does is that the client there is your single point at which that all the data flows through. And this provider component, which is something that's provided by Bicycle, sets up that client as part of the context for your entire application, which means that all of the connect components lower down the tree can access the same instance of the Bicycle client. On the server side, you can create a Bicycle loader. I'm running a bit low on time, so I'm not going to go into too much detail on this, but broadly speaking, this will keep re-rendering your application until there are no requests in flight, until all of the data has been loaded. So, interactivity, it's the final part of the list of abstractions that we needed in order to get this working. So there are two types of interaction. There's navigation, which we've kind of spoken about a little bit before, and there's updating data. Most things fit into one of those two categories. Let's talk about navigation first. The key thing when you think about any kind of interaction in your application that I'd like to encourage everyone to consider is it really navigation? Often we think that something is just a state change when actually it's navigation. So an example of this is if you have like a show hide button and then a section of your application that kind of animates and shows and animates and hides, that's navigation. Anything where you're changing what's visible on the screen, but you're not updating any data in any database, that's navigation. And what that means is that we can represent that with a link. We can represent the button that triggers that change as a link. And if we do that, it will naturally work with or without JavaScript. With JavaScript, we can handle the navigation via the HTML5 push states using something like React Router. And we can do the fancy animation where the part of the page shows or hides. But when we don't have JavaScript, they'll click on that link. They'll still be taken to the new URL. It'll load the new URL from the server, and the server can simply immediately show the additional content. People miss out on the animation, but they don't miss out on the content that's in that show and hide section. Another thing to think about with interactions, if for some reason a link isn't an appropriate way to represent that interaction, is that you can fall back on small bits of JavaScript that can kind of polyfill the bits of interactivity you need without necessarily loading your entire React application on older devices. If you're doing that, it's worth being aware that there are some users who do not have JavaScript at all. And that doesn't necessarily mean they've disabled JavaScript. It doesn't even necessarily mean they're on an extremely old or device that doesn't support JavaScript. It might just mean they have a really weak internet connection or an intermittent internet connection, and your JavaScript simply failed to load. I think the BBC, no, sorry, I forget that. I think the UK government did an interesting experiment into how many users didn't have JavaScript enabled. I encourage you to Google that. I think they found it was like 1 or 2%. It was quite significant. So the other type of interaction, updating data. Most updates to data can be represented as a simple form post. So you can have an input elements, buttons, and what have you, all wrapped in a form. And that will work on the oldest of browsers. That's worked since the beginning, almost the beginning of the internet. So it works great on the server, but you can also simply attach the onSubmit event on the client, handle this in the browser and the client as well. And you could abstract that into some kind of universal form component and make it call the appropriate method on the client and also post the appropriate message to the server, which means you can solve this once for your entire application and then reuse it everywhere. So some closing thoughts. I'd like to briefly impose upon you this thought of why you shouldn't care about the server side. So be aware that search engines these days run JavaScript. If you're doing this purely for search engine optimization, it's probably not worth it. Yes, search engines might do a slightly better job if they don't have to run your JavaScript. But I think Google is using a fairly recent version of Chrome to render websites in order to do the search indexing. The other thing to think about is that if you're rendering on the server side, but the interactivity requires JavaScript, then you're sending people something that's not interactive initially. So that time to interactivity can be just as important as the time to display, the time to show something. Another thing to think about is that rendering on the server side uses a lot of extra resources. This might be something you could dynamically turn off when you detect that you're under really heavy load. But in general, it's gonna cost more to render on the server side. So yeah, something to bear in mind. If you are thinking about rendering on the server side, if I haven't put you off, then this is kind of the checklist of things to think about for any kind of interaction. So firstly, will the server-side implementation do? Do I need to even build any kind of client-side implementation for this feature? So for example, links for navigation. Links for navigation work great. If all your site has is links, don't write any JavaScript. Next up, can you enhance the interaction with some small amount of JavaScript? So a good example of this is form posts, where we can provide a much better experience by updating just the bits of the page that have changed using JavaScript. But we can still build it as a proper form so that in the absence of JavaScript, it continues to work. Next up, can I get away with implementing this only for the client side? For example, there's no need for fancy animations if the user doesn't have JavaScript enabled. So for those kind of things, you just don't need to worry. Yeah, and if you have any kind of critical applications and there is no way to build them in a purely server-side way, then think about separating off just that small bit of the JavaScript, maybe making that a separate script that loads before the rest of your JavaScript just to get that kind of critical path working smoothly. Cool. I've got a few minutes to take any questions, I think, if there are any. There's one at front.
Yep. Right. So in the company I work for, we have this kind of like religious avoidance of the words full stack developer. We kind of split between front end and back end, and we kind of follow that quite strictly. It has helped us, be more productive and everything. So from my end, as a front end developer, everything I see here is like totally impressive. I mean, if I could just let go of my PHP Smarty templates and everything and just use JSX for my whole stack, that'd be amazing. But is it worth my colleagues, a PHP developer or a Perl developer's time to go to them and say, look, you know what? I would like to use React on the server. But he's going to turn back to me and say, okay, but we're not installed in Node.js. Would you advise, if you know that you cannot use Node on the server and you have to rely on the existing stack, PHP, Perl, Python, is it worth the effort to do that? Or perhaps?
So there's lots of options. One thing I think that's really worth considering is having kind of the front-end, back-end developer role, which is someone who maybe builds a Node.js application that sits in front of your traditional PHP or Java or whatever back-end application. So your back-end developers still focus on the sort of traditionally back-end tasks of making sure you have optimized queries and well-structured REST endpoints and all of that kind of thing. But then you leave the work of building the user interface to front-end developers who build the client-side JavaScript and a small, thin server-side JavaScript layer. Now, that still requires you to host some Node.js somewhere. Another alternative, and this is something I think we do with some very small bits of Facebook, although I'm not certain on that, is you could run a Node.js server kind of off to one side and ask your backend developers to say, when you're rendering this little bit of this page, do it by making a request to this Node server and then using the result of that. That can be kind of cumbersome and inefficient, but it's an option. Failing that, you could write your application twice, write the PHP version, the JavaScript version. I'm not convinced that there are, I think if you're kind of in that situation, I'm not convinced there are enough users who really don't have any JavaScript at all to justify that for most organizations. So I think probably I would fall back to, at that point, rendering just a shell. So something with kind of an indication that it's loading, an indication that something's happening, maybe the navigation elements, and then render the rest on the client side. Okay. Any other questions? Okay, I think we can finish there then. Thank you.